Binary search is one of the most efficient and fastest searching algorithms. If you want to ace any coding interview or just program in general, binary search can be one of the most powerful weapons kept in your arsenal. Unfortunately, people find it a bit difficult to implement binary search, and hence, a very popular programming language's standard library had its erroneous implementation for quite some years. But do not worry, after watching this video, you will be able to solve almost any problem of binary search for integers in an error-free manner. So smash those subscribe and like buttons and let's get started. First of all, we need to identify if a problem can be solved using binary search or not. After solving a lot of problems, you get kind of a mental radar by which you will be able to detect if the problem can be solved using binary search or not. But until then, problems with keywords like minimum, maximum, and places wherever you can imagine things to be sorted have a very high chance that they can be solved using binary search. Let's take the classic sorted array example. Say we are looking for the number 4. We start by dividing our domain into trues and falses based on a certain condition. Here, let's take all numbers less than or equal to 4 to be true and let the rest be false. Remember, we are always interested in finding this junction of true and false. Once you are able to divide the search space like this, you can be sure that it can be solved using binary search. Writing a function to check if our search parameter, which is index in this case, is at true or false is very easy here. Let's call it our checker function. It accepts the search parameter index and returns true or false accordingly. Now we take two markers, high and low, just outside our search space. These are placed just outside to handle the case where the entire array might be true or false. But relax, we will never have to use our checker function outside the domain. Here, low always remains in true domain while high resides in the false one. We calculate mid, which is low plus high minus low by 2, or simply low plus high by 2. This is done to prevent integral overflow. We calculate mid, which comes out to be 4, and since it lies into the false domain, we will update high. Again, mid comes out to be 1, but this time it is into the true domain, so we will update low. This time it is equal to 3, which lies in the true domain again, so low will be updated. Finally, mid comes out to be 4 and high will be updated. Notice that we are at the required junction now and the difference between low and high is equal to 1. This will be our stopping condition. Let us now write some C++ code. I'll start by including the header files. We'll need IOStream for input-output purpose and vector to create dynamic sized arrays. Now let's write the checker function. It's gonna receive a vector of integer elements and I do not want to make a copy, so I'll pass it by reference. I'll need the index and I'll also need the target element. And this function can simply return that b at index is less than or equal to the target element. Now we'll create our binary search function. The role of this function is to return a -1 if the element does not exist in the V and its index otherwise. So it's gonna receive the vector itself. Again, I do not want to make a copy, so I'll pass it by reference. And I'll need the target element that we'll be searching inside V. I'll create the two markers, low, which will be -1, that is just below the lower range, and high, which will be equal to V dot size. Now high is already just outside the above mark because of zero based indexing. So for example, if our vector is of size 10, then it will have the indexes in range 0 to 9. So -1 and 10 will be the initial low and high markers. Now we write the while loop. While low plus 1 is not equal to high, we'll calculate mid, which will be low plus high minus low by 2. And if the checker function will pass v, index will be mid and target will be the target itself. So if this returns true, so basically if it is equal to true, or we can simply omit this, then we will update the low marker because that is supposed to reside in the true domain. We can say low is equal to mid, and otherwise we can update high. Now finally we can return low because that is equal to true, but remember we also need to put a check if the element exists there or not. So we can say if v at low is equal to the target element, in that case we can return low and -1 otherwise. Finally we can write the main function. Let's declare a sample vector over here and insert all the numbers from let's 1 to 10 in it. Finally we can call the binary search function. It's gonna receive the vector, the target element, let's say that is 4, and we'll simply print a new line. So that is it for the code. Let's try to run this. We will compile our file by saying g++ and then your file's name. Now g++ is going to invoke the compiler drivers and compile the file. So it compiles it into a file called a.exe if we do not use the flag otherwise. We can see that a.exe an executable is created in the same folder. Now we can execute that. Now you can see the binary search function returns the integer 3, which is the index of number 4 inside our array. Let's also check if the element does not exist inside the array, then our code works correctly or not. So we can change this by let's say 20. Compile successfully. And now if we try to run the code, then it returns -1. Binary search is extremely fast and works in order of log n time. You can show this world that you are even faster by pressing like and subscribe button with bell notification on. If you want more such videos or have a topic in mind, then feel free to comment it down. This is PS Coder signing off. See you in the next one.